Okay, in this next video, I want to look at two different types of functions very quickly. We've got root functions and reciprocal functions. A root function is when we have an exponent that is to a fractional power in the form 1 over a number, like 1/2. X to the 1/2 power is the same as the square root of x. And I can show you very quickly what the graph looks like. The domain of this function does not include negative numbers because we can't take the square root of a negative. The square root of 0 is just 0, so it's going to start off at the origin, and then as x grows, y grows as well, but it gets less and less steep as we go to the right. We can also look at another example, x to the 1/3, or the cube root of x. And this one has an important difference. Here we are allowed to take the cube root of negative numbers. Now the cube root of positive numbers will be positive, but the cube root of negative numbers will be negative. And so our graph ends up looking something like that. It's meant to be symmetrical here, but I did not do the very best job of drawing that. And it's a little bit similar to the square root on the right here, but it ends up being a little bit less steep. So this is what root functions look like. If it is an even indexed root, like a square root or a fourth root, the graph's only going to be up here in the first quadrant. But if it's an odd indexed root, we can take the odd root of a negative number, so there's going to be a portion down here in the third quadrant as well. So those are a couple of examples of root functions. I want to look at one more in this video, a famous function, the reciprocal function, which is going to be f of x equals 1 over x. This is an interesting function. In fact, I'm going to use proper graph paper for it. I'm not using proper graph paper for all of them because it would take a very long time. There's a lot of videos in this lesson, and I don't want this to be a lesson that takes students an exorbitant amount of time to get through. But I think this is a good one to actually be a little bit more specific about what the graph looks like. If x equals 1, 1 over 1 is just 1. So this is going to include the point 1, 1. And then if x is 2, this becomes 1/2. So we've got the point 2, 1/2. If x is 3, we get 1/3. If it's 4, it's 1/4. And basically, as x is getting bigger, the denominator getting bigger means the fraction is getting smaller, and it is going to be getting closer and closer to 0, but it's never actually going to become 0. And it's never going to become negative. Basically, the denominator growing makes the whole fraction become smaller and smaller, but there's no negative here when x is a positive value. So we're never going to cross over the x-axis down there. Now, if we pick values of x that are less than 1, there's a few things we have to worry about. First, we can't pick x equals 0. That is not in the domain. That's the only number we can't divide by. So in fact, we can tell right off the bat the domain is all of the numbers x such that x is not equal to 0. So then what's going to happen over here? Well, if we pick smaller and smaller values of x, the function ends up growing. If you pick x equals 1/2, 1 divided by 1/2 ends up being 2. And if you pick x as 1/3, 1 divided by 1/3 is 3. And we actually see some behavior that's a little bit similar from what we saw on the other side. In both of these cases, the graph is getting closer and closer to the axes. Now, when we pick negative values of x, 1 over a negative number ends up being negative, and we're going to see very similar behavior. I don't want to take too much time in graphing this, but we end up seeing very similar behavior where the graph is asymptotically approaching the axes, meaning it's getting closer and closer without touching or crossing. Now, of course, I'm not perfect. I mean for this to get closer and closer without crossing, but I'm a human being, not a robot, so my graphs won't be perfect. But at some point, the distance between the graph and the x-axis is smaller than the width of the pen or the marker that you're using, so we can only do our best to make it look like it's not crossing.